Hi, everyone, welcome to my channel again. Today, I am going to share about confidence interval, which is an important concept in statistics. Before watching, please like, comment and subscribe to my channel. Your support will encourage me to produce more videos related to Lean Six Sigma and operation management. The first step of every statistical analysis is to determine whether the data that you are dealing with is a population or a sample. The population is the totality of items, while sample is a subset of the population or portion of the whole and, if properly taken, is representative of the whole. A descriptive measure of the population is called a parameter. A descriptive measure of a sample is called a statistic. What is an inference statistic? The statistical inference process involves the use of a known sample statistic to arrive at a judgment about an unknown population parameter. If a researcher gathers data from a sample and uses the statistics generated to reach conclusions about the population from which the sample was taken, the statistics are inferential statistics. The data gathered from the sample are used to infer something about a larger group. A common sample statistic of interest are sample mean, sample standard deviation and sample proportion. Application of inferential statistics. One application of inferential statistics is in pharmaceutical research. Some new drugs are expensive to produce, and therefore tests must be limited to small samples of patients. Utilizing inferential statistics, researchers can design experiments with small randomly selected samples of patients, and attempt to reach conclusions and make inferences about the population. Suppose another company developed a new process for prolonging the shelf life of a loaf of bread. The company wants to be able to date each loaf for freshness, but company officials do not know exactly how long the bread will stay fresh. By taking a random sample and determining the sample mean shelf life, they can estimate the average shelf life for the population of bread. Two types of estimate in statistics, which are point estimate and interval estimate. What is point estimate? Point estimate is a single value, known as a statistic, computed from sample information, which is used to estimate the unknown population parameter. A point estimate is only as good as the representativeness of its sample. If other random samples are taken from the population, the point estimates derived from those samples are likely to vary. Different samples from same population will give different point estimate statistic result. A point estimate, because it is a single number, by itself provides little information about the precision and reliability of estimation. A researcher for the company takes a random sample of 85 mechanical parts for a recent month and from these parts computes a sample diameter mean of 4.9 millimeters. If the company uses the sample mean of 4.9 millimeters as an estimate for the population mean, then the sample mean is used as a point estimate. Limitation of point estimate. Sample is a subset of the population. It is unlikely that the sample statistic is identical to the population parameter. Due to sampling variability, we are uncertain how close sample statistic to population parameter. Our point estimate could be very close, or it could be far from the true mean. A way to avoid this is to report the point estimate in terms of estimated range called confidence interval. What is confidence interval? Confidence interval is an estimated range of values which is likely to include an unknown population parameter, or we could define confidence interval as an interval estimate of an unknown population parameter, with a specified level of confidence of the estimate. The interval is generally defined by its lower and upper bounds. A confidence interval always specifies a confidence level, usually 90%, 95%, or 99%, which is a measure of the reliability of the procedure. Confidence level of an interval estimate, 1 minus alpha of a parameter is the probability that the interval estimate will contain the true population parameter. The width of the interval conveys information about the precision of estimation. A short interval implies precise estimation. We cannot be certain that the interval contains the true, unknown population parameter. We use only a sample from the full population to compute the point estimate in the interval. However, the confidence interval is constructed so that we have high confidence that it does contain the unknown population parameter. How to interpret 95% confidence interval? We are 95% confident that the interval between x lower bound and y upper bound contains the true value of the population parameter, or we are 95% confident that the true value of the population parameter will fall within the x lower bound and y upper bound interval. We are 95% confident that the interval between 23 and 28 contains the true value of the population mean, or we are 95% confident that the true value of the population mean will fall within the 23 and 28 interval. Most confidence interval has the following form: sample statistic plus or minus critical value multiplier, standard error of sample statistic. Sample statistic plus or minus margin of error. Examples of confidence intervals are confidence interval for mean, confidence interval for variation, and confidence interval for proportion. Factors affecting the width of the confidence interval: sample size, standard deviation, confidence level, significance level. The width of the confidence interval decreases as the sample size increases, as the standard deviation of the sampling distribution decrease. The width of the confidence interval increases as the standard deviation increases. The width of the confidence interval increases as the confidence level increases. The confidence level is defined as 1 minus alpha. Common convention in economics and most social sciences sets confidence intervals at either 90, 95, or 99% levels. In practice, we wouldn't want to set the confidence level below 90%. From the table, it shows that the width of 95% confidence interval is wider than 90% confidence interval. The width of the confidence interval increases as the significance level decreases. Alpha is related to the confidence level. Alpha is the probability that the interval does not contain the unknown population parameter. Mathematically, 1 minus alpha equals confidence interval. From the table, it shows that the width of 0.05 significance level is wider than 0.10 significance level. In summary, the statistical inference process involves the use of a known sample statistic to arrive at a judgment about an unknown population parameter. Different samples from the same population will give different point estimate statistic result. A point estimate, because it is a single number, by itself provides little information about the precision and reliability of estimation. We can, however, create an interval that includes the true population value with a specified probability, using certain statistical procedures, known as interval estimate. Confidence interval is an estimated range of values which is likely to include an unknown population parameter. A confidence interval always specifies a confidence level, usually 90%, 95%, or 99%, which is a measure of the reliability of the procedure. 4 factors that affect the width of the confidence interval: sample size, standard deviation, confidence level, significance level. Thanks for watching. Remember to subscribe to my channel. Bye, see you next time.